Hey, hello devs. Welcome to my channel Crosscut Dev Talks, and today we have another problem and theory, right? To cover, right? So we'll be covering sequential programming and parallel programming, right? So in the last video we have just covered the theory of polymorphism, right? The compile time and the runtime bindings, right? So we have seen one problem, and we have just by doing some codes, and we have debug the code, and we see like how the object is behavior uh, object is changing its behavior compile time to runtime, right? So today we have important topic like sequential and the parallel programming, and this topic is been asked by many of the interviewer. And if you're preparing for any interview, just please focus and just uh, try to learn, right? The basics we will be covering, the theory part we will be covering, and then we'll jump into the coding section, right? So the coding section is not that much, right? It's a 30-40 lines of code, and we'll do the code, and we'll see by debugging the code like how the both one is different from each other, right? So what is your waiting? Let's jump into the theory section first. Okay. Yeah. Okay. Here we go. So the problem is stated, right? So we will be comparing the sequential and the parallel. Parallel is just async, right? The payment processing in C sharp, right? So we have a payment processing like the problem we have designed, right? So it just we have simulated the payment processing method, right? So once I'll do the code, I'll show you, and showing how running tasks in parallel can dramatically reduce total execution time when operations are independent. Please focus on this one. When operations are independent, right, then only parallel programming will, will be beneficial to use, right? So, and it's advantage, right? So, it's, both one is having its own pros and cons, right? Okay, let's go to the problem explanation, right? So there are two ways provided to process the payment for multiple cards, right? If there is a problem and there is a scenario, we have to do the payment in bulk, right? So we have to process the multiple cards, right? So there are two ways we can do it, right? So we'll be writing two methods, process cards and the parallel process cards. So these the name is distinguish the functionality, right? So in the process cards, we will just process the card sequentially, right? So what it's saying, process card payment one after another sequentially. Means like once the payment is done by one card, so it will initiate the payment for the with another card, right? So waiting for each payment to complete before starting the next, right? Okay. What's the parallel process cards? It's saying start all cards payment at once, right? So it won't wait, right? So it will have all the payments, sorry, the cards, and it will just initiate the payments for all cards at once, right? So we can distinguish, right? So when we are waiting one operation to complete, and we are restarting the another operation when it's the first one complete, so it will take time, right? But if you think, right, technically, right, so in the sequential programming, right, we have the control over the program, right? And there is a scenario, right? So when we want the control and there is a code, we have to like the code written after this sequential calls, right, is dependent on that one, right? So we should be waiting for it, right? We should not just say that just we cannot fire and forget, right? Because we are using the result of each payments, right? We are checking what is this, whether it succeeded, failed, or what is the, if there is problems, so we have to log it, right? But in parallel programming, we don't care, right? So we just fire and forget, and we don't. And in this scenario, we don't have much control over the process and the threads, right? So, and the scenario when we could use the parallel programming is right when the operation is independent. We don't care about what is the results and we just fire and forget the operation, right? So so using these operations, this programming method, performance will be better, right? And if the processing can be concurrent. Okay. So let's compare both one like there as I earlier said, right? So there is pros and cons of each method, right? So sequential is just basically let's first discuss the sequential. So as I said, it's easier to debug, right? We have the control on the program and or on the execution, right? We can debug it, right? And is cons is it's just slow, right? Slow in the sense of right, it's just waiting. It's just wait for the thread to be completed, right? Then the further steps will be executed. Okay. And the next process good if access the resource must be we want to see less thread resource just right. So we have the response and we want to work on that response. And so that we are talking about here, right? It's not efficient for high volume operation, right? Yeah, definitely. Because if we have 100 and maybe 20, 30, 40 operations and we are running the process parallelly, not parallelly, sorry, sequentially. So it will take time. So it will slow down the execution and it will impact, right? So it will impact on the latency, right? Okay. So let's discuss the parallel programming, right? So this is the method name we will be having in our code, right? So much faster if operations are IO bound, right? So what does it mean by IO bound, right? So when we are having RPC code, right? Remote processor codes, right? So when we are calling some third-party services, right? Using HTTP client, right? In .NET we have the HTTP client class, and we can just call the third-party services using that, right? So database connections, right? DB operations, okay? So all these are I operations, right? So it will be good to use the parallel programming on the I operation, right? And having said that, harder to debug, right? So we don't have the control and we cannot debug what's happened, right? When we have just parallel calls, right? We don't know what's happened in the calls, right? So all payments can be processed at the same time, right? So what it will do, it will just process all the threads parallelly, right? It won't wait for one over other, right? Yeah, we in parallel programming, we don't wait for the results, right? We just fire the request and we forget, right? So this we are talking about it. Need extra care, yeah, definitely, because we have the threads and the resource. We should be caring about the each threads, right, and the resources because it's just use the resource, right? So it's an IO operation, so it's use the resource and the networks and right. So we should be careful, like about the memory leaks, right? And we should be disposing the disposable objects, right? Before after the process has been done, right? So we should be more careful on this one. Right? Okay, so let's discuss the problem, right? What's the problem? Okay, so imagine we have 10 customer cards, right? So if each charge takes 1 second, so we are talking about like when we do payment and each payment is taking 1 second, right? So in sequential way, right? We can think about it, right? It will take 10 seconds. We have to wait for one card to complete, right? Then it will start another one, right? So it will take 10 seconds, right? So with parallel approach, so all cards are charged at once, right? So it's a parallel code, so all 10 cards will be charged at once, and so it will take approx 1 second. Okay. So this description we will be simulating through writing some codes, right? So let's have some definitions, right? Sequential process means, right, executing the task one after another, right? So it's more clear, right? Where each next operation begins only after the previous one finishes. That's okay. Parallel processing refers to executing multiple tasks simultaneously, right? So it's saying like, so we have 10 threads, so all 10 threads will be running on the same time, right? So utilizing threads or async mechanism, right? It will be using the threads and the async patterns, right? So operation can run independently and complete faster. Yeah, that's true, right? So all operations are independent. That's only we can use this one, right? So we don't depend on the response, and that's how it's complete. It's faster, right? So asynchronous programming, right? So let's discuss what is asynchronous programming. We have been talking about these async in all the previous discussion, right? So it's a way to structure the code so that slow down like network calls and delays don't block the program's main flow, right? So when we have the IO calls, right, so we don't want to block the thread, right? We just want to release the thread so that it will be available to the next operations, right? So we'll be using the synchronous programming, right? So what it will happen, it will just internally there is a state machines, right? So it will create the state machine and it will just mark down that the await call, right? So it will release the threads once the response comes back. The state machine knows from where it has to resume the execution, right? Task-based programming, right? So task-based programming use the task class to represent asynchronous operation, right? Both are, we should be saying both will be used uh, with each other, right? So making it easy to handle the multiple ongoing activities, their completion status in .NET application, right? So this task is basically more useful when we want to check the status of the, any .NET process that has been I operation that has been done, right? Okay, so this all we have discussed about the theory, right? So I hope this theory has been maybe clear to all of you, right? So if there is anything, any confusion, just write me down into the comments. I will go through the comments and I will try to answer, right? So and please encourage me, right? So subscribe the channel and write down the comments and like it, right? So if possible, share it as well. And in the comment section, please write down if you want to see any next video on any specific topic. So I'll be listing down uh, into my definitely list, right? So I'll try to cover that, right? Okay, so let's jump into the code. Yeah. Okay. Let's create public class. Okay, process card parent. So this is a class, right? So we are creating this class. So I'll be discussing and explaining, right, what is the role of this class, right? So public class, right? Card, right? Let's create this card class. Okay. Any suggestion for pilot, please? No suggestion. Okay, fine. That's fine. That is fine. And that is fine too, right? Okay. And that's fine. Pilot, please help me. Yeah, that's fine. So this is the card, right? This is the card class, right? So this is the basic properties of this card class, right? ID, card number, folder name, expiry date, right? So here, what we will have, definitely, we'll have this method. Yeah. Okay. So let's. process payment. Okay, wait. So public enumerable card. That's fine. And I would say generate cards, right? I think Tokai or Copilot has given a suggestion, right? That's great, right? So what this method is responsible for? Okay, so generate a list of card objects with dummy data. Okay, so the number we will be passing to this method, it will generate that number of cards. If we are passing 5, so it will create the 5 cards. And if we are passing 10, it will create the 10 cards, right? Okay. Process payment by right. So let's have enumerable, right? By enumerable, right? Okay. Oh, it's fine, right? So let's have for each. That's fine. Async. Wait, we want it async, right? Sorry, not async, right? Task, right? Okay. So process payment by card, right? And let's create another method that we really want. Public async task process payment. So it will process the payment for a card, right? Just pass that card. And yeah, that's great, right? We are delaying. So what we are doing, so we are simulating the payment processing delay, right? So it's not having the actual implementation, but what we are saying here, delay the payment for 1 second, right? Okay, that's fine. I think this is really fine, right? So let's do it. Async of it, right? Okay, so let's do one more thing. Let's create the instance of stopwatch, right? So we want to see how much time it is taking, right? Let's start this stopwatch. Stop this. Log it, right? It's fine, right? I think this is fine now, right? And yeah, this I get. So let's generate 10 cards, right? Okay. So Copilot is giving me suggestion, and that's really great. Okay. So we are good to go, right? So what we have? We have this. Let me do one thing, right? So let me put this method out, right? Or it's a main method, right? Okay. Static async math. Why not? Okay. Do we want it? Just give me a moment. What's the problem is, right? Okay. No space, right? Just it only, right? That's it. Okay, so just problem. Right on it, right? Okay. sorry for this, right? So just okay. This is the closing layer. This is closing layer, right? And okay, I will write down it somewhere else, right? Let's see. It's closing layer. Right. So let me just copy it and record. Okay, same column like that. Write that down, right? So don't know what problem it was, right? So I just want to wait, invest more time here, so the video will be too large, right? Okay, so the same thing, right? So we have the process card payment class, right? So it has generate cards method. The number of count will be passing here. It will generate that number of cards, right? So the process card method, right? We have the stopwatch starting the stopwatch, stopping the stopwatch, and just logging the time as we can, right? So this is the process cards, right? So we will discuss this parallel processing cards uh, after that one, right? So let's see. Let me let me so let me go identify. So what we are doing here. So we have the list of cards, right? So we are processing each card one after another, right? So we are awaiting the calls, right? So we are waiting for. So this is so we are waiting the one thread to be completed so that another thread will stop, right? So this is the example of this sequential programming, right? So it's just step by step execution, right? So oh, let me I don't want to debug it, right? So let's see how much time it will be taking. So it should take ideally 10 seconds, approx 10 seconds. Uh, there can be a gap of some milliseconds. Let's see. Come on, come on, come on. Okay, okay, come. Okay, so great, right? It's taking 10,000 milliseconds, right? So it's approx 10 seconds, and that's we have been discussing the same, right? So it's a sequential calls, and the thread is blocked, halted by 1 second to, and once it's wait for 1 second, it will start for the another execution. So it will take the so step by step, it's to process the 10 cards. It's taking the 10 seconds. Okay, let's discuss about the parallel code, right? So we have created then some stopwatch, that's fine, right? So what we are doing here, created the list of tasks, right? So and what is the difference, right? So here we are waiting for code, right? But here we are not waiting for code, right? So it's just returning the task, right? The task is, we can say that, the reference of the method. So we can say that we have the reference of this method in this task, right? And this task we are adding into this list of tasks, right? So for 10 cards, it will just loop through and add all these 10 cards here. And what we are doing here now, we are waiting here and saying, let's process all these 10 tasks parallel, right? It's not sequential, not one by one. It's saying, let's fire all these 10 threads, 10 tasks, and let them execute. So when all these 10 threads will process, so it will gonna complete in 1 second, because there are 10 separate threads running, right? And they are independent from each other, right? So it's ideally should be taking 1 second, and there can be a gap of some milliseconds that earlier we have seen in case of this simultaneous calls, or sorry, not sequential call. Okay, let me run this one, and let me let me run this first, and then I will take a Come on, come on, come on, come on. Okay, this is the sequential code, right? Oh my God, my mistake, right? So I have not uncommented this line, right? So how did I achieve it? Correct. This is a main method, and the process starts from here only, right? Okay, okay, 10 seconds, and we see sequential call 10 seconds, and we can see thousands millisecond, right? It's just approx 1 second only. It's a uh, it's not sequential, it says parallel call, right? The sequential call is taking 10 seconds, and the parallel call is taking approx 1 second, right? So this is the one method, right? Main method, creating the instance of this payment process class, right? We have this payment process class, right? We are generating the 10 codes. We are processing these 10 codes. We are passing these to this method, right? This method, these 10 cards, and these 10 cards, and this method is processing the payment for each card, and this method processing the payment for each cards at once, right? So this is the difference, right? So this is the coding part, I think. I hope this is clear now, right? So if there is anything, any confusion, just write me down into the comment section. I'll just review that comment, and I'll just cover. I'll try to explain, right? Okay. So let me give the final thought, right? So let me open. Okay. So this is the sequential, and this is the parallel. Let me separate it down. Okay. So general, assign it some block only. Okay. So, okay, let me copy it. Okay, right, right. Come here, come here, come here, come here, come here, right? So how many it is, right? It's six only. Let me delete this. Let me take the example of six one only, right? Okay, right. This is the card one. This is the card two, card three, card four, card five, right? So each card is taking 1 second to process, right? 1 second, right? Let me write it down for understanding purpose. This is taking 1 sec, 1 sec, right? And 1 sec, right? This is also taking 1 sec. Okay, so card one, 1 second, card two, 1 second, three, 1 second, four, 1 second, and five 1 seconds. One, two, three, four, five, right? So total is, so if you see, total equal to 5 seconds. It's okay, right? So in parallel programming, what is happening? Right, we have this one, right? So copy this one, right? Card 2, card 3, card 4, and card 5, right? So the execution start at same time. They execute at same time, right? So if we try to depict it from the diagram, so if you see, this is the sequence, right? One after another, right? And this is the parallel, right? At the same time, all has been fired. So 1 second, in 1 second, all five cards has been completed by that payment, right? So I hope this is I'll be able to explain you. If there is anything as I was saying, right, just write me down into the comment section, and please subscribe, like, and share, right? Thank you. Stay tuned and happy coding.